Hello guys, this is David. In the previous lectures, we have gone through displacement, velocity, and acceleration analysis based on vector approach. In this lecture, we will first explain to you the reason why we need a computer-aided design, or in short, CAD program for mechanism designing. Then we will list out some popular programs with such functionality. And last, we will introduce you a CAD program that we developed. Not only that, in the following lectures, we will provide you a detailed walkthrough to help you to understand the mathematical background of these programs. Now, let's start with the reason why we need CAD program for mechanism designing. In order to give you a better idea about what the designing process is like, here I'll show you an excerpt from the video released by Disney Research Lab. Okay, from the video just now, we saw the most common goal that people have during the designing process, which is to design a mechanism whose motion follows a particular trajectory. In order to achieve this, it is necessary to perform displacement analysis every time after the mechanism is modified, or altered if you will, so that the designer can tell whether his or her design has met the requirement or not. However, it is obvious that if we have to go through the analyzing process using vector approach once every time after the mechanism is altered, it is not only monotonous but also time consuming. Not even to mention that when it comes to dynamic analysis, we will have more equations to solve. Oh, and by the way, you don't have to worry about dynamic analysis right now. It will also be covered in the following lectures. Due to the reasons that we have mentioned above, it is clear that if there were a CAD program with capability of performing kinematic or even dynamic analysis on any given mechanism, it will be a great relief to the designer and will definitely facilitate the designing process. I hope this is enough for you to understand why we should have a CAD program for mechanism designing. And now, I have listed out some popular programs with such functionality in case that you happen to have such need. One thing that I really want to mention here is that none of these programs is really capable of performing dynamic analysis, but it is definitely enough if all you need is kinematic analysis. Last, I would like to demonstrate the program that we developed. This program is capable of performing both kinematic and dynamic analysis. Since all we have talked about so far is kinematic analysis, therefore, in the following video, we will demonstrate how it is like to perform kinematic analysis with our program. First, the panel on the right-hand side is where the user can design their own linkage system. For instance, say now we want to build a linkage system that looks like this. It is clear that what we need are two anchor points and three bars, which can be easily generated by clicking on the buttons right here. Next, we just need to arrange these components according to the mechanism that we wish to analyze and set the driving link of the system. Once that is done, click on the MATLAB button over here and set the simulation interval. Then the program will automatically generate the corresponding MATLAB file to perform kinematic analysis on the system. And now the analysis is complete. These graphs shown here are the displacement, velocity, and acceleration of each rigid body at each step within the time interval. And all these results will be automatically saved into your computer in case for further study. What's more, it is even possible to view the simulation result through animation, just like this. Okay, thank you for your attention. This is the end of this lecture, and in the following lectures, we will guide you through all the mathematical background of the programs we mentioned above. So stay tuned.